Hi everyone. I've had some students ask about truncuses and how to find x-intercepts. So I've got an example here. I did go through this in a Zoom session this week. If you didn't attend that Zoom session, perhaps that's something you could start doing, is attending those non-compulsory Zoom sessions and make sure you're getting help when you need it. But thanks for those people that have emailed through for help. So I'll go through how to graph this and pay a little bit of attention on extra attention on finding x-intercepts. So our vertical asymptote is at x equals -3. Remember, it's the opposite sign of h. Our horizontal asymptote is y equals -4, same sign of k. And the y-intercept, we make x equals 0. So we get y equals, should be a y equals at the front there, 1 over 2 bracket 0 plus 3 squared, take 4. 1 over 2 times 9, take 4. 1 over 18, take 4. 1 over 18, take 4 times 18 is 72. So that's 72 over 18. So we get -71 over 18. So our y-intercept is 0, -71 over 18. Now for x-intercepts, we make y equals 0. Now remember, the first thing we want to look at is, are A and K the same signs? And if they are, there's no x-intercepts. In this case, they're not. They're different signs. So there can be x-intercepts, or there will be x-intercepts. So we've made y equals 0. First thing you want to do is add 4 to the other side. Next thing we can do, now it's at this point where a lot of students have trouble. So what I am going to suggest, I'm going to do a little bit of extra things on the side here, just a bit of extra explaining. If we had 12 divided by something equals 2, we would know the answer to be 6, because 12 divided by 6 is 2. But how would we get it algebraically? Well, it's currently dividing by x, so we would multiply by x. So we'd get 12 equals 2 times x. Then we could say it's multiplying by 2, so we could divide by 2. And we know that 12 over 2 is 6. So we get the right answer. But what have we actually done? Well, have a look here. The x is on the bottom and the 2 is over here. And by the end of it, the 2 is on the bottom and the x is over here. What we've done is we've actually swapped our variable, we've swapped the denominator of our fraction with the thing on the other side of the equal sign. We've done it by multiplying by x and then dividing by 2. We've swapped them. So whenever your variable is on the bottom of a fraction, you can swap it with the other side. And that is mathematically correct. It's mathematically sound to do that because you're doing 2 steps at once. You're multiplying by the x and you're dividing by the 2. So let's apply that to the question with the truncus. Let's have a look here. So this is our denominator of this fraction. So our denominator is part of a big clump, our variable is part of a big clump on the bottom of a fraction. So we can actually divide that, swap it with the other side of the equal sign. And that's the bit that's going to make this stuff a bit easier. So I get 2 bracket x plus 3 all squared is equal to 1/4. Then we can divide by this 2. So 1/4 divided by 2. 1/4 divided by 2 is the same as 1/4 times 1/2. So that's an 1/8. My next step, I'm going to get rid of this squared. Now when we get rid of a squared, we square root. And when we're getting rid of a squared, we have to find the positive and negative root. So that's going to be the positive and negative square root of an 1/8. Now we can leave it as that, or we can make it the square root of an 1/8 is the square root of 1 over the square root of 8. Well, the square root of 1 is just 1, so we can get rid of that little square root. And then we can rationalize, which means timesing by the surd on itself. So we get root 8 on 8. Now root 8 is root 4 times root 2, which is 2 root 2. So we get 2 root 2 on 8, and then that can simplify. So the square root of 1 on 8 is actually root 2 on 4. they mean the same thing because we've rationalised it and we've simplified the surd. So we get root 2 on 4. You can rewatch that working out if you're not sure how that happens. So it's root 2 on 4. So we get x plus 3 equals positive or negative root 2 on 4. Hopefully that makes a little bit of sense, but we'll keep going. Then we can minus 3. So instead of writing positive or negative root 2 on 4, take away 3, I'm going to write it as negative 3 plus or minus root 2 on 4. And they're our x-intercepts. So when we put all that together, we have asymptotes at negative 3, negative 4. So x equals negative 3 is an asymptote. Y equals negative 4 is an asymptote. And our y-intercept is negative 71 on 18. Now remember, we got negative 71 on 18. Oh, it's not, the working out's not there anymore. Negative 71 on 18 is slightly less negative than 4. Remember, 4 times 18 is 72. So this is slightly above negative 4. In other words, it's right on the edge there. Excuse me while I let my wife in the house. So we've got our y-intercept. It is 0, negative 71 on 18. And now we graph it. Now we know it's a positive truncus because our a is positive and our x is positive. So it's going to look like this. And remember, we don't want to bend up, and we want to make it somewhat symmetrical. So now it's just our x-intercepts to label. Now, I didn't really have to worry about this answer of our x-intercepts because the graph showed me where it was. So this one's obviously going to be negative 3 plus root 2 on 4, and then and 0. And this one will be negative 3 minus root 2 on 4 and 0. So that's how we graph this truncus. The x-intercepts, it's quite tricky to do that. The y-intercept gave us a fraction, but that's all okay. Be okay with the surds and the fractions, and if you're not sure how to do them, you obviously need to put some more work into that. But hopefully that makes sense. Let me know if there's any issues.